Okay, we're going to now learn how to calculate the sample standard deviation, and we'll start here with a really small data set. Okay, so the first thing you need to do is you need to find n and x bar. So n here is just 4 because there's 4 values in the data set. Okay, so the mean, I got to add up these values, so I get 32 divided by 4, divided by the number of values, and this ends up being 8. Okay, so you got the sample size, n is 4, x bar is 8, and what you're going to do is you're going to place these into the formula. So the x bar goes up here, the n goes down here. Okay, and it's very important that they go in the right place, and then you don't want anything in there for x. X is like a variable. So this is what I would write. I would write that s is equal to the sum of x minus 8 squared divided by 4 minus 1. Okay, and I'm going to take the square root. And so this is the numbers here plugged into the formula. Okay, and so when you look at this formula, the confusing thing is this top portion, because it uses that sum notation, and so that's just very strange. So what I want you to do, and this is going to help out a lot, is put a light circle in for that top portion, and then do the 4 minus 1 and write 3, and then put the square root over that. And so what you see here is all you need is the number that would go in there for the top, and then you just divide it by 3 and take the square root, and you get the standard deviation. So to calculate this and get this number, we're going to use a table. And the table has 3 columns. And the columns look like this. So the first column, I'm just going to list out the values in my data set. And those are the x values. Now if you look at this column, x minus x bar, that was the formula for the deviation. So these are actually the 4 deviations. It's how far each value deviates from the mean. So 10 minus 8 is 2, so it means 10 is 2 units above the mean. 7 minus 8 is negative 1, because 7 is 1 unit below the mean. 3 minus 8 is negative 5, because 3 is 5 units below the mean. 12 minus 8 is positive 4, because 12 is 4 units above the mean. Okay, now at this point you can check your work and make sure you're doing everything right. And the way that you do that is that this column should add up to 0. And the idea here is that the mean is actually the data point. The mean is actually the balance point of the data set. And what that means is that all the deviations below the mean balance all the deviations above the mean, so that the data set balances there at the mean. So it means these positive deviations, 2 and 4, I get 6, balance out the negative deviations, and negative 1 and negative 5 is negative 6. So positive 6, negative 6 would give me 0. Okay, and that should always happen with that middle column there. Should cancel out and get 0. Okay, and this will always be 0 if you don't have to round the mean. So we'll have an example where you have to round the mean, and in that case you're going to be using something that's not quite the balance point, and then when you add these up you'll get something really close to 0. But if this comes out equally, these will exactly balance out. Okay, so now what this column, what you're doing here is you're squaring the deviations. See, you got the deviations and that quantity squared. So you're squaring each one of these, and if it's a negative deviation, then it's going to be, if you have a negative deviation, when you square a negative number, it becomes positive. So 2 squared is 4, negative 1 squared is positive 1, negative 5 squared is positive 25, and then 4 squared is 16. Okay? And then let me warn you real quick about if you're using your calculator to square the numbers. If I hit negative 5 squared, I'm going to get negative 25. Okay? And so, but it should be positive 25. Okay? And the reason for that is that if I write in negative 5 squared on my calculator, exponents come before subtraction. And so it's going to square 5 first and then take the opposite. So this is actually what it's going to do. And that will be negative 25. Do you see? It's squaring 5 and then it's taking the opposite of that. So what you would actually need is a parentheses like this so that it'll take the opposite first and then square. And in that case, it would be like this. Negative 5 times negative 5, which is positive 25. Okay? So you would either need to put negative 5 in parentheses to get the positive 25, or if it's a negative number, just square the positive because they both equal 25. Okay? The negative squared and the positive squared, if it's the same number, they're both positive. Okay? So you could just ignore the negative signs as you square them if you're using your calculator. So now, once you get to this part, you're going to add this column up. So I get 20, 45, 46. Okay? And so this 46, this is the number that you put in here into that circle, 46. Just like that. And so now you finish your calculation by doing 46 divided by 3, and then I would hit equals, and you get what's underneath the radical. And then what you can do, since that's a repeating decimal there, is you can hit your square root, wherever that is on your calculator, and then you should have some button that says answer. I know for the TI-30s, you have to hit second, and it's like a button down here somewhere. In this case, it is one of the buttons. And what that's going to do is it's going to take the square root of whatever's in the, whatever you calculated previous, that's in the answer line. And then there you have the standard deviation, 3.9. So this is 3.9. And that will be your standard deviation. So again, let me show you. I would do 46 divided by 3, hit equals, standard deviation of the answer, hit equals, and you get the standard deviation. Okay? And so that's how you calculate it. So a couple things real quick. When you, the reason for doing this with the light circle is it's going to remind you that you're not done until you fill in that circle and then complete the standard deviation. So this is very helpful. And also, sometimes what people end up doing, if they don't use this and they just have this, they end up taking 46 and plugging it in for x, subtracting 8, and then squaring, and then they just ignore that, and they just get completely the wrong answer. Okay? This number here goes in for this entire portion here. Okay? And let me see if I can explain why. This is the sum of these things. And these things are the squared deviations. Okay? So what this means is take each value, subtract 8, so find the deviation for each value, and then this means square all those deviations, and then this means add them up. And then that's what that whole thing is. So this is the sum of the squared deviations. And this table is a real nice way of doing that. So let me do one more example with a few more values, okay? So in here, n is equal to 8 because there's 8 values. Ooh, 1, 2, 3, 4, 5, 6, 7. Oh, there's not 8 values. You know what? That's the one I was going to have you do in the next video. This is the one I was going to do. Okay. So, n is equal to 8, and then I need the mean of these. So I got to add all these together. So I'm going to add them up. 14 plus 12 plus 21 plus 16 plus 22 plus 9 plus 16 plus 10. So add them up, I get 120, and I'm going to divide that by 8. So divide this by 8, and I get 15. So my mean is 15. So my n is 8, and my mean is 15. So now I'm going to plug these in to the formula. So I'm going to have the sum of x minus the 15, that quantity squared, and then on the bottom I put the 8, I put the n, so n minus 1. It'll always be minus 1, that's part of the formula. Okay, so you got to make sure that the mean goes in the top part, the n goes in the bottom part, and then I always put this, I put a light circle here for this portion, divide that by 7, and then I take the square root, and then that reminds me here I just need to use my table to get that top portion. So the table here, I'm going to list out the x values: 14, 12, 21, 16, 22, 9, 16, and 10. So now I got to get each deviation. So just keep in mind the mean is 15. So 14 minus 15, that's -1. 12 lies 3 below the mean. 21 lies 6 above the mean. 16 lies 1 above the mean. 22 lies 7 below the mean. 7 above the mean. 9 lies 6 below the mean. 16 lies 1 above the mean, and 10 lies 5 below the mean. So I have the negatives and the positives. These should cancel out. So I check my work here by adding them up. So that's -4, -10. That would be -15. And then this is 7. And another 7 is 14, and 1. That's +15. So like I said, those will cancel out as long as the mean, as long as this divided evenly and you didn't have to round the mean, those cancel out. And so now the final column, I'm going to square each one of these. So 1, 4, 36. Oh, not 4. What am I thinking? 9. 1, 9. 36. 1. 49. 36. 1. And 25. So now I add these up here. 1 plus 9 plus 36 plus 1 plus 49 plus 36 plus 1 plus 25. And they all add up to 158. And this sum is what goes in for that top portion. So I fill in my circle with 158. Okay. And so 158. So now I'm going to take 158 divided by 7, and I get what's underneath the square root. Now I'm going to take the square root of the answer, and then I get the final answer. And I'm going to round to the tenths place. So this would be 4.8. So approximately 4.8. And that would be my standard deviation. Okay? So again, You start by calculating n and x bar and putting those into this formula. I would do this. That is very, very helpful to see what you're doing. And then to get that top portion, make the table where you list out your x values. These are all the deviations. Positive if they're above the mean, negative if they're below the mean. These will cancel out. And then this is just the square of all of these. And they're all going to be positive. And then when you add those up, then that becomes the top number over here. Then you just divide it by 7 and take the square root, and you get your standard deviation. So that is how you calculate the standard deviation. So like I was saying before here, I'm going to have you do this one in the next video. So maybe I'll erase this. And what I'll do is in the next video, we'll start here, and then I'm going to have you pause, and then I'm going to see if you can calculate the standard deviation.